start a meeting by thanking everybody. How was Clevaligner born? Well, as you probably know, I used to work in the 2000s in a large company, and this is when Invisalign was marketed. And my boss back then told me, well, it's never going to work. And every year he would tell me, well, they invested in scanners, they invested this and that, and they lost the equivalent of 600 million euros. And so my boss, Cybran Dental, back in those days, early 2000, he thought that he would never make it. He was a visionary, that gentleman, but not when it comes to aligners, because as you know, we were discussing that during the round table. Dr. Bouquet will write a summary of what we talked about during the roundtable. As you know, the topic was, are brackets going to disappear and be replaced by eyeliners, or are we going to have hair treatments? Well, this being said, I've been selling brackets for the last 25 years. And so I thought, well, that'd be great if one day I could have my own aligners. You have many companies printing aligners, but they do not have the engine, if you will, the engine being the software. And I thought that, well, it's not going to be possible that myself, Charlie Kubi, by myself, there's no way I'm going to develop such a powerful software. But it so happened that I was in Harvard in 2018, and someone told me, well, you know, nowadays with AI, we analyze radiographs, we can do things automatically. You do not need to have all those manual steps. And so I thought, well, let's get in contact with a number of players. And I asked them, well, would you like to invest in my company? So I contacted orthodontists, I contacted general practitioners. To begin with, we had 400,000 euros. We thought that the budget would be enough to develop a software based on AI, but unfortunately, that was certainly not enough. The key opinion leaders working in this area said, well, this is not the quantity of money you are looking at. I remember that we had some very heated discussions with engineers, so we had to leverage more funds. But it so happened that in 2019 I created this company named Clevaligner. The idea was to develop a software which is different from everything that we have on the market, which is going to make you more independent and also more powerful in your way and better serve your patients. Now I'm going to give the floor to YEHIEL. He's the representative of the technical team. He traveled all the way from Tel Aviv to talk about the software. Good morning. Well, first, I hope this is going to be a welcome change. I heard very much about brackets and TARDs. I have to admit that I didn't understand everything. There are a number of things that I had to implement in the software, but a number of concepts I had a hard time to grasp. This being said, it was extremely enriching, and I'd like to thank you very much for your respective presentations. As Charlie said, I'm in charge of IT. I've been doing that for quite a while in his company. Working with Charlie is quite an experience, and working for Clevaligner was, for me, a change in approach. It's obviously a very innovative approach, and that's usually the case when you start a project like that, cutting-edge project. But management was very different in this project. Usually, when someone comes and sees an IT engineer, they come with an idea and they ask us to design a solution. And the manager has a number of ideas, and the chief technology officer, they think about a program, an agenda, a timeline, and to say the truth, well, we never meet the timelines. But that's the way we go about projects. Now, with Clevaligner, it was a completely different process altogether. There was a team which came with manager. A number of them are in the room. There was a very good collaboration, but also there was a very good supervision, if you will. So on a regular basis, we organized meeting with permanent updates, our project being challenged on a number of occasions. And so we created this virtual circle whereby engineers, project managers, CTO would meet. We would also take into consideration the feedback of orthodontist. And from that point of view, of course, it was not always very nice meetings in that we had a number of challenges that we had to face. Sometimes some roles would overlap. CTO and project managers would do different things, but you have to realize that orthodontists were always our key concern. Well, it comes with a set of benefits, but also drawbacks. The product that we propose is the real reflection of a need feedback from the field. Well, obviously, I know that other companies work with orthodontists because IT engineers usually are not trained in dental school and vice versa, so it's very rare that you have the double skills. But we had a very close collaboration, and we were able to harvest insights from the field. We had a good sense of what they needed, and we were able to address their needs. So a number of meetings. We also benchmarked what was available in the market because we have a number of aligner brands on the market because we started investing in this area. And there were three critical areas. First, we draw up a list of the faults and gaps of the existing softwares. And we try to place ourselves in the shoes of the orthodontist and try to see what they like. When you use a software, well, when an orthodontist uses a software, they have to get trained in using the software, and there's a learning curve. And placing ourselves in the shoes of orthodontists and clinicians was key in order to take into consideration a number of features that are not necessarily present in other softwares. Softwares obviously keep evolving, there are constant updates, but sometimes you need to have very deep-reaching changes in the software core in order for the software to really meet their needs. We really also envisaged very closely the relationship between clinicians and computer. We really wanted to have a win-win situation. We wanted the orthodontist to remain the director of the orchestra and the IT technicians on the computer to also play a significant role. When we started benchmarking the market, we noticed a number of things. First thing, when you think about Invisalign as a brand, but there are many others, which of course creates a form of monopoly. But what really struck was the impact of the software. With Invisalign, quite often the software decides on the number of things in that the orthodontist is going to send the STL file and the 3D data. They are going to input a number of instructions and preferences that are going to be taken into consideration or not by the Invisalign technician, talking about solving the deep bite or the open bite or intruding, etc. And a team is going to create the segmentation. It's by no means automatic. So human beings are going to improve the setup, and then the setup is going to be forwarded to the clinician. That's an issue. Of course it works. It works in a number of cases, but the fact that the technician, quite often not an orthodontist in the first place, is making decisions based on the clinician's prescriptions. And sometimes they make decisions, and even if they're orthodontist, and I heard that many a time, when you review unconventional cases, there are different ways to solve the same case. So 1/3 of orthodontists have an approach, but then 30% are going to follow a different avenue. So even if they were an orthodontist, we all have different ways of treating, different habits, different skills. Also, they may have a different patient base with a different setup. In the same line, but tackling this from a different perspective. When you send those files and you fill in a form, the form is pretty much binary. You have closed question, you answer with yes or no. Would you like to treat that or that? And we've seen that yesterday. This was a very nice presentation, usually clinical presentation, and the decision-making process of a human being is never binary. Cell force. You are not going to compromise bone for pain. You're never going to compensate pain by an approach. And starting a treatment with binary questions to try and encapsulate a reality which is nothing but binary requires a number of compromises. The last point. Today we all traveled by plane. None of us swam across the pond or the Atlantic, and so we placed our fate in the hands of AI, because planes pretty much today embark AI. Some of you probably have e-cars, smart cars, and so there's usually two groups. One group of individuals who are ready to hand over their fate and their health to a healthcare professional. That's the case when you use Invisalign, where you hand your fate to a technician, and so the software is mostly used for communication purposes. You upload files, but another individual is going to set up, and I suppose this is pretty reductive to the ability of the software. Today softwares can pilot planes, you can use softwares to detect malignancies, and I suppose that you can give a larger role to IT. So once you reach those conclusions we said in the introduction, what Charlie envisaged is to fully use and fully leverage AI. When you embark IT specialists from the onset, you solve a number of issues. First, you reduce delays, and you reduce the timeline. It's more instant when you use computers, because they work at weekends, they never tire. You know, they are the perfect employee, they are high performance, loyal, never late. That's the perfect employee, but that's a machine. So it's more accurate, it's instant. And as an aside, it also solves a number of underlying issues, in that a number of software of the market, if not all, between the time you place the order And the moment you actually receive the set of aligners, they are delivered to the practice, you may have to wait for anywhere between 14 to 30 days. So sometimes you have to wait as much as 1 month. And in the meantime, you've had a number of back and forth messages sent by the technicians. Some clinicians are highly skilled and they've been so used to the software that there are not so many back and forth communication, but it's taking a while. The feedback from clinicians is such that some are rather independent and others are going to extensively communicate with the technicians, and this adds up and it increases the timeline. And it increases the timeline. Yes, Charlie is instructing the speaker to be quicker. And so we're talking of 2 weeks to 1 month between the moment you place the order and the moment you actually receive the aligners. Now, if you integrate AI, you can solve a number of those issues insofar as things are performed instantly, and the time frame would only comprise the delivery time. So if you live in a close vicinity to the lab, we're talking about almost instant to maybe 7 days of delivery. The other advantage is that for complex cases, you know that complex cases are difficult to solve with conventional solutions because there are limitations with those different solutions. Now, if we add something extra, so the software is going to be different. It's going to embark AI, but AI needs to be customized to each clinician. It's going to be based on their habits, treatment habits and skills, their treatment philosophy. And so if we customize AI in that respect, we're going to get better success rate and we're going to solve more complex cases. We're going to have a rate of up to 70% in complex cases, which is actually not the case. So these were the preliminary steps. Before I show you a demo, I'm just going to present the timeline. So the file was uploaded to the servers. Data are summarized and assessed. AI is going to compute the arch form, is going to identify the different teeth units, and then by combining AI and algorithms, we get very accurate contours. So in a way, we short-circuited the step where a human being needs to contour and individualize each tooth. From that, the areas are pretty well defined, and from that, again by applying algorithm, we can compute the size, the midline, the arch wires. We can also change the angles, the tipping. We can also apply torque on the roots. We have the center of resistance and also the 3H. So once all those data are embarked, we are in a situation where you have a preliminary setup. So to the left, you have the setup as reviewed by the software. So the teeth are properly delineated. The angle and size is well registered. And once you have this set of data, what you have are the 8 criteria that you need to plan your treatment. Contact points. We also look at root angulation. We look at closal contacts, overjet. And eventually, this is the final stage. So to the left, those are raw data. And the more you go to the right, you have the progress of setup. So those are naturally raw IT data, but the computer has the ability to propose something which is pretty much optimal. There's also another piece of information that you need to take stock of. Once you have it, you have to print the eyeliners per se. With other companies, you do not necessarily have your say. You want to go from A to B, only from A to B. There may be collisions, there may be some rotations that are going to interfere with our teeth movement. So what we need is a form of intelligence which we add to the software, and the clinician can immediately select the teeth that are going to start the movement, what's going to be the reciprocal impact on linear position of the other teeth, on potential rotations, and can also propose alternate provisional positions in order to get the desired result. Now, if we look at benchmark and the competitors, there are advantages that we have that our competitors don't have. So what we propose is a comprehensive system embarking AI with customized AI. By customized, we realize that each clinician has a set of patients. The more patients they have, the richer the database. And when the database is rich, it's integrated retroactively in the software. It's going to propose very customized treatment solutions. So you have those different benefits that you get and that other competitors do not have. So full control, speed changes in order to get to the right situation. Also, we completely overhauled the design, looking from the outside in order. Sometimes we got inspired from other dental softwares. When we talk about dental softwares that are not necessarily ortho softwares, the way radiographs are going to be laid out on the screen, we need the photographs, we need complementary data that sometimes we do not have when we plan treatment. Also, I cannot disclose the full information because it's still an ongoing process. You have to know that we were granted FDA approval, so the device is approved, can be marketed, it's medically stable, it meets the standards designed by the United States. In Europe, we have filed for CE marking, so shouldn't be too long, and we also patented the device. We reached the first milestone in that we need to prove that there are no equivalent on the market. The idea that we want to patent does not exist on the market. Again, it's ongoing, so for legal reasons we cannot disclose, but what I'm trying to tell is that we are going to significantly shorten treatment times. So the patient comes in, we sell the file, you do not have to wait for 3 days to get your setup and your segmentation, instant segmentation, and then you have your 3D representation, and except for a number of features, in many cases, the clinician is going to change a number of things. They have a checklist, smile in the face, potential IPR, potential overjet that they want to change, but instantly they are going to get in 3D with 80% of the work already done by AI. That's a significant benefit, and that would make for a smoother experience. With that, I'm going to show you very quickly a demo.
I'm going to show you some demos. Here I have some demos for attachments and stripping. I have them in my computer because I didn't want to depend on the internet. This is the original and the treatment suggested. We can apply the attachments. Here we correct intrusion, extrusion. When the doctor arrives in the 3D, these are the suggestions, but then he can make changes, modulate. according to his or her wishes. Here we have Bolton, the Bolton table measurements, stripping. We can check every tooth before and after. And then the attachments can be applied. There are different types of attachments. I mean, other software can do it, but this one is a bit more flexible because you can apply several types of attachments, control their depth, their size, and it provides better control on the movement. That was the attachment demo. This is another demo on how to create a patient. This is a test that was conducted. You see the images have been revised. Classification depending on tasks that are pending, in progress, at different stages. We have all the patient records, the notes. So that's the patient creation. It's very simple. Name, email, address, 3D files, pictures and x-rays are an option. Treatment, that's it. In a matter of minutes. We have a 3D image. Here we have a suggested treatment. And you see how the doctor will see how he moves the teeth, not linearly, one after the other. Here we have two more features that could be interesting. We wanted to be to make you, to put you in a position to control printing with the aligners. It might be interesting to print the aligners. Sometimes you want to give 30 aligners to your patients, but you want to only print 15. Then after the 15, you redo a 3D scan to assess the evolution and maybe take in consideration a few changes that may have happened. Some patients have longer or shorter routes, and the treatment advancement may vary from one person to another. So it's sometimes necessary to only print half the aligners and then make a midway adjustment. There's something else I wanted to show you. I think EMERIC can show you. There is a way in the software to choose. Yeah, I'm going to show it. I'm going to show you. Don't spoil my presentation. Okay, that's it. I've shown you everything. The website. There's a website. We have a website on which you can find information on current progress, and also you can register to be contacted. As soon as we can exit the very limited group of doctors who are already using the software, you will be contacted. This is the demo. Precision details. Liner control. You can register to be contacted, and we will contact you as soon as it's available. Thank you for your time. Thank you for your attention.